the square process, it might be helpful to know why we even need to learn it. Okay? And the reason that we learn it, I'm just going to pull one up here. Is if I have a problem like this. Up till this point, we know how to factor. Okay? So let's try and factor this. We're looking for factors of negative 15 that add up to 6. Three and 5 are factors of 15, but they don't add up to 6. 15 and 1, 3 and 5, that's about it, right? So there are millions of equations that are quadratic equations that are not factorable. But we still have to figure out the solutions, what the zeros are, what the roots are, what those solutions are. Okay? And so the next couple sections, that's what we're going to be learning. 2 different strategies to solve equations like this one when they're not factorable. Okay? One strategy is called completing the square. Another strategy is using the quadratic formula. Okay, so we're going to learn completing the square today. And the purpose of completing the square, if you remember when we did the section on solving quadratics, if we have something like this, right? Once it's in this form, to solve it is pretty easy. What do we do?
X squared plus 3, x squared plus 2 equals 7.
Nope.
They both equal to 7.
That's true, but what do?
You need to factor in the exponent.
Take the square root of both sides.
Yeah.
I take the square root of this and the square root of this plus or minus. X plus 3 equals plus or minus the square root of 7. Then I subtract 3. And I've solved it. Okay? So if I could get it into this form, or something, it's not going to be that exact number all the time, but if I can get it into that form, I can solve it.
Yeah.
So completing the square is, the whole purpose of it is, number one, it's not factorable. And number two, it's going to give me an equation like the one on the top right that will allow me to solve it. So what I'm going to do is try and figure out how to create a perfect square binomial, because that's what this is, a perfect square binomial. If I can get a perfect square binomial on the left equal to some number on the right, I can then solve it because I know how to do that. But this is not anything I can do at this point until I get a perfect square binomial on the left. And to do that, we have to do a process called completing the square. Okay? So now let's jump into how we do this. So again, eliminate factoring. If it's factorable, that's the easiest way to do this. Factor it and be done. Set it equal to 0, set each of your factors to 0, and solve for x. Okay? So go through that process first. Ask yourself, is it factorable? If it is, factor it and be done. If it's not, then one way to do this is to do something called completing the square. Okay? So to start completing the square, you're always going to move the constant to the right. And I always leave a space here because I'm going to fill that up. With me so far? All I did is I moved the constant to the right. So I just have the x squared term and the x term on the left. Okay. Now what I want to do is figure out how to make a perfect square binomial so that if I expand it, I have x squared plus 6x plus something. Okay. The way to figure out what that plus something is to take your middle term, divide it by 2, and square whatever that is. 6 divided by 2, 3 squared, 9. Yes, but whatever I do to the left, I must also do to the right, or I've totally changed the equation. Okay, so I have to add 9 to the right. Now, this is factorable. This is one of those special factorings that we learned in section 2. This is a perfect square, this is a perfect square. It factors to x plus 3 squared. Okay? And I can check it, because remember, to find the middle term, I take this term times 2. X times 3 is 3x, 3x times 2 is 6x. Okay, so I have factored this now to get a perfect square binomial on the left, which is what I wanted.
I'm confused how you got that.
What, this?
Yeah.
I just factored this.
Where did you with the 9 over here though?
I added 9 here, and I had to add 9 here. Okay, so I'm adding a constant here to allow me to factor it like this. So by adding the 9, so I could factor it like this, to the left, I have to add that to the right. Can't just add it to the left, because now my equation is lopsided. Okay, and so on the right then, I have 24. Now if I'm going to solve this, I just take the square root of both sides. And I get x plus 3 equals plus or minus the square root of 24. Well, the square root of 24 can be simplified. 4 times 6, right? So it's 2 square roots of 6. And now I'll subtract 3. And I'm finished. X is either negative 3 plus 2 square roots of 6 or negative 3 minus 2 square roots of 6. Okay? Again, don't go through this process if it's factorable. It'll still work, but why would you want to do that to yourself? Just factor it. We know how to do that. This is only when they aren't factorable. Okay? Now, it gets just a little more complicated when that leading coefficient is not 1. Okay? So I'm going to go through 2 ways, and you can choose which one makes the most sense for you. One way is the way they presented in the textbook, and one way is the way they presented in the video. Okay? So they're both equivalent. I'm not trying to show you that you have to do both ways all the time, but I want to give you some choice and see which one you are most comfortable with doing. Okay? So I'm going to flip to another example. Okay, first way, you start the process exactly the same by moving the constant over. Now I'm going to go ahead and factor out on just the left side that 6, because I want just an x, a 1x squared, not a 6x squared.
It's 36.
Huh?
The other number's 36.
I just wrote, I don't know what you mean.
Never mind. I'm just confused.
This is the problem I started with. I'm just giving that one to you as the problem I started with.
Head is what I did.
Okay. So I'm going to factor a 6 out. Okay. All I did is factor a 6 out.
I thought that we had to divide by 2.
Not yet. I'm not to that point yet.
Oh, gosh.
You can't start that process until you've got just an x squared term.
Oh.
That's why I'm factoring the 6 out. Okay, now I'm focusing on the parentheses. Okay, now I'm going to do that, Tristan. How do I find that constant?
Divided by 2. So
Okay.
the term,
So negative 2 divided by 2 is negative 1.
negative 1, and then
Negative 1 squared is positive 1. Okay, so this becomes positive 1. But did I just add positive 1 to the left? No. What did I add?
negative
Nope. Look at my parentheses.
You
What's
put it
in
in a parenthesis.
I did. So what's in front of it? I added 6.
Oh.
Right? Because I have to distribute that 6 to the 1. I have the 6 on the outside, and I put everything in parentheses. So don't just add 1 to the right. Add 6 to the right, because that's what I really added to the left. Still with me?
Yeah.
Okay, now I can simplify this. I still have the 6, but this can be now factored to a squared binomial, which is the whole point of completing the square, so I can get that squared binomial. Right? And that's equal to 13. How do I solve this now? Can't take the square root yet. You have to isolate the parenthesis, the perfect square binomial. Divide by 6. Okay? So I have x minus 1 squared equals 13/6. Now I'm going to take the square root of both sides, plus or minus. And I have x minus 1 equals plus or minus the square root of 13/6. Well, I have a radical in the denominator. Right? So to get rid of it, because this is the equivalent of this. What's 13 times 6?
72. No, 80.
20, 18 times 84. I said 84, and I wrote. Okay. Can 4 go into 84?
No, it's 78.
Okay. 13 times 6.
It's 78.
Okay. Is this divisible by a perfect square at all?
No.
So this is really plus or minus 78/6. Square root of 78 over 6. So x is equal to 1 plus or minus the square root of 78 over 6. Okay, that's one way when that coefficient isn't 1. So I'm going to go through the same exact problem another way. So I want you to really think about which one makes the most sense to you. And then when you start practicing these, practice that way. Okay? So let's start with the same problem. I'm going to move this. I'm still going to move this 7 over. But now what I'm going to do is just divide everything by 6. Still with me? Now, I'm going to look on the left. Again, it's plus 1. So I have to add plus 1 here. Then I can factor this. And this is 7/6 plus 6/6. And I'm back down to x minus 1 squared equals 13/6. Right? Take the square root on both sides.
I don't know how you get x minus 1.
This, I'm intentionally adding 1 here so it can factor to this.
So you're just moving that number down.
I'm factoring this.
So you divided it by 2.
I'm factoring this. I'm thinking of factors of, okay, so if I were just given this problem and asked to factor it, I would be looking for factors of 1 that add up to -2.
Okay, that makes sense now.
But But I'm intentionally adding this so I can factor it.
I understand.
Okay. So then I just get x minus 1 equals the square root of 13/6, and I do the same thing, and I get the same answer. Okay. Where this one can get a little more complicated is if I had, let's say, instead of 12x, I had 13x. If I add 7, okay, factor, divide everything by 6. Now to find that middle, that constant, I have to divide this fraction by 2 and square the fraction.
That's hard.
But it's still doable. If I divide it by 2, all I have to do is multiply the denominator by 2. Right? So when I divide this by 2, I get 13/12. And when I square 13/12, I get 169 over 144, which I then have to add. Get a common denominator. So I'm just dealing in fractions there. Okay, but either method, whether you just factor the left and then remember to multiply that factor by whatever constant you add to the right, or just factor the 6 out of the whole thing.
I like the first one.
Okay, that's what I mean. Everybody's a little different. Okay, so let's look at the textbook check. Okay, so when completing the square, to find the constant term, you use the following equation.
B over 2 square root of 2.
B over 2 squared. Yep, B over 2 squared. To complete the square when the coefficient isn't equal to 1, you first need to divide every term by the leading coefficient. Find the value of C. Well, 2 divided by 2 is 1. 1 squared is 1. The video was from Khan. No, I think it was the yellow screen, right? Which is James Souza. To complete the square, you determine the value of the constant and add that value to both sides. Add that value to both sides. Okay? That's it.